this situation. 7 quantity 2 plus 9. In this case, because I can perform this operation and I get 11, I will write 7 times 11 and get 77. Yes, of course, I will get the same thing if I distribute. If I distribute 7 to 2, I get 14, and then plus 7 to 9, and I get 63. And when I add these two, I still get 77. So I illustrated the distributive law. Here in the first row, I illustrated how to use order of operations. I perform the addition first because it's in parentheses. It has more priority. I should say more importance. Okay, I'm done with this, and then I multiply by 7 and get 77. Now, if I'm asked to use the distributive law, that's fine too. 7 times 2 and 7 times 9, and I have to add them. One more example I would like to look at. If I have negative 5, any questions, please? Never hesitate to ask questions, please. So negative 5 and 4, negative 2, negative 1, 2. I have a bunch of, what are they? What are these numbers? Are they terms or are they factors?
Factors.
They are all factors. And remember, when we have only factors, we dictate the order. We dictate the grouping. We can do whatever we want. So here's what I mean. 2 times 4 times negative 1 times negative 2 times negative 5. Or negative 5 times negative 1 times 4 times 2 times negative 2. It doesn't matter. What I am going to do first, though, that's not important. The final answer is not, the discussion is important. But thank you, Rachel. Just 1 second. So, I'm not interested in the final. I'm interested to explain what's going on and what would be the first step. I see 1, 2, 3 negatives. First, I will take care of the sign. Always. In a chain of factors, I will first take care of the sign. And then, you don't have to rewrite them again, but I'm going to rewrite them. I don't want to put this here because there is no room. Okay. You can rewrite them as 5 times 4 times 2 times 1 times 2. But first, please, always take care of the sign first. And now you can do whatever you want. 4 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. And then you have negative 80 as the final answer. So the crucial part to understand here is there is no need for you to carry and multiply negative, positive, negative, positive, negative, positive. No. Always look and see, oh, 3 negatives? Okay, the sign is negative. 2 negatives? The sign is positive. 4 negatives? The sign is positive. 5 negatives? The sign is negative. So I counted. There are 3. Put the sign first. And then simply multiply all positives. 5 times 4 times 2 times 1 times 2. Of course, there is no reason for you to write multiplication by 1 because we know it doesn't change anything. And 2 formulas here for areas because you're going to need those. So for the area of a rectangle, the area is length times width. And for a triangle, one formula, we have several formulas, but one formula is if this is the base, the corresponding height has to be perpendicular to this base. What I'm saying is if this is the base, you cannot use this height that is perpendicular to another side. You have to use base times height, or base times height, or base times height. It has to be the corresponding height, perpendicular to the given base. So the area of the triangle is base times height, like here, base times height, but divided by 2. So it's basically the same formula. This one is not divided by 2, but this one is divided by 2. Any questions before we start the exponential rules? But I'd like to stop for a few minutes and see, because I don't think you can open the practice. I will open the practice for 1.2 because I think you have to do the learn first. So I will open mine because they, as you know, they always give different problems. Even to me, every time I click, there is a different problem. Okay, so let's work on a few problems. I'm going to click on 13. I don't even know what to expect. Okay, perform each operation indicated. So what will you say about part A? So let's work on part A. 24 divided by -3. 24 divided by -3. First, take care of the sign. First, division of a positive number by a negative number. First, take care of the sign. Put it in front. And then you can do whatever you want with the rest. The sign first, so you don't make an error. So, what will you say? The final answer. Again, Pavlos and Lindsay, I haven't heard from you. And Ty, and Ariana, and Arian. Anybody? So, what do you think? Anybody, please, help.
-8.
-8. Very good. -8. Perfect. Let's work on another now. Again, I don't know what to expect. So let's see what they're giving us. Okay. Perfect. Find the value of the missing number. So put x over -3 and 0 over 1. X over -3 and 0 over 1. And use the proportion and see what you come up with, please. Do we have an answer?
We've got -3 over x.
Good. So you will cross multiply. And what do we get? X times 1 is x times 1 is x equals -3 times 0.
0.
That's it. Go back and double check. Is it true? Is 0 divided by -3 0 or not? Is it yes or is it no?
Yes.
Yep. So that's it. Let's look at another. We will always stop. We didn't do it the first day because I talked so much about the course and the syllabus. We will always stop and work on problems. So use the associative property of multiplication to rewrite the statement using the property. So let me copy the statement, which is 6 times 8 times 2. How will you rewrite this statement? Using the associative law of multiplication. It's okay if you're wrong.
Oh, would it be 6 times 16?
So remember the law, very good question. So here's the law. The associative law of multiplication says grouping is not important. We're not calculating anything. It's just to show what it equals to, but not the final answer. So if we group the first two and then multiply by the third, is the same with grouping the last two and multiplying by the first. So what I have to do is just rewrite this piece here. How do I rewrite that? Yes, I see that. That's correct. Thank you. Well done. So, can anyone help now? No, we don't want the number. The number is not important. We just want to show that this is the same with 6 times 8 multiplied by 2. That's all we're asked to do. And maybe later on they're asking us to multiply. Good. Good. Please work on these problems with me so you realize when you have questions. Okay. Calculate each of the following. So let's calculate, you choose. Let's choose one and calculate it. So we can move on. Which one we want to work on? Any?
I did negative 30 times 5.
Negative 3 times... oh, you mean part C? Yes, that's fine. Good. So first of all, please take care of the sign. So negative 30 times 5. Now, in the same way, because 5 is positive, there is no need for parentheses, but that's okay too. It's not a mistake. But please remember, first, take care of the sign. When you take care of the sign, negative times positive gives us what?
Negative.
Indeed. And now you simply multiply 5 by 30, and you get a negative 150. Good. Okay, let's see what else is here. Find the perimeter and area of this rectangle. So I'm going to graph it here. I'm going to copy the graph. So we have a rectangle, which is 9 feet in width and 30 in length. So they want us to find the perimeter and they want us to find the area. So let's take a moment and let's see what else is here. Now let's do that. Okay, and then something else. What is the opposite of 10? Okay. Good. So let's find the perimeter and the area. Remember the formulas? If you need them, I'll write them down again. we need the formulas? Are we okay with that?
For the perimeter, you have to do 9 plus
9 times 2 plus
2.
30 times 2, or vice versa. 2 times 9 plus 2 times 30. And for the area, you have to do 9 times 30. So the perimeter, we are adding quantities. So this, first of all, we have to perform multiplication. So this is our first priority, and then addition and subtraction. So 9 times 2 is 18, 2 times 30 is 60, so the answer is indeed 78. The measurement unit is crucial. Can anyone give us the measurement unit for this?
Feet.
Say it again. Feet, indeed.
Feet.
Yes, perfect, feet. But now when we write the area, 9 times 30 is indeed 270, but what is the area, measurement unit for the area? It cannot be the same. Why? Because here we're adding, and here we're multiplying. So here they're old terms. 9 plus 30 plus 9 plus 30. I'm adding quantities. I'm adding apples to apples to apples to apples. But here imagine like I'm multiplying an apple by an apple, which cannot have the same measurement unit. Yes, apple squared doesn't exist, I know. But when I multiply feet by feet, what do I get?
Feet squared?
Indeed, feet squared or square feet. Understand that adding is one thing, multiplying gives us a different situation. Good. Okay, any questions? Okay, we had, I just opened another example here. What is the opposite of 6? Can anyone give us the opposite of 6?
-6.
-6. Very good. Okay. I'd like to continue with exponential rules. Let me stop sharing. Exponential rules. This is an exponent. Have we seen exponents before? Yes, right here. This is the exponent. It tells us how many times the base appears in a product as a factor. How many times? 2 appears 5 times. 2 times 2 times 2 times 2 times 2. 3 appears, the power is 1, because 3 appears only once. So this is what we call exponential notation. Okay, a raised to n power. So nth power, also called exponent. And this is called the base. So the base appears n times. A simple numerical example, a to the 4th power. Means a appears as a factor, not added or subtracted. That would be a term. So a times a times a times a. So a appears as a factor 4 times. The base is a, the power is the exponent. Okay? So when we add a plus a plus a plus a, I'm adding a pencil plus a pencil plus a pencil plus a pencil, and that is 4 pencils. But here when I multiply, It's a different story. Okay, perfect. Of course, every time a notation was invented, it came with millions of rules. I'm exaggerating, of course, not millions, just a few. Okay, here is the first rule. A raised to the nth power times A raised to the mth power. My n has 2 bubbles, my m has 3 bubbles. I hope I'm not confusing you. So this, when we multiply exponential notations with the same base and different exponents, or even it can be the same also, we copy the base. Copy the base. Do not touch the base. Do not do anything to the base. Just copy it. And then add the exponents, n plus m. Some time ago, maybe an hour ago, I said, maybe an hour and a little bit, I said, if we go this way, it means this. If we go this way, it means this. Pretty much the same thing here. This is also a dynamic relationship. What does this mean? It means that from this side, I can get to that side and also back. From this side, I should be able to come up with this. So if I see that the exponent of this quantity has 2 quantities added together, I know they come from here. Multiplication of the same base with those exponents. So I can go back and condense, and I can go back if you want and expand. Okay, next. So again, how do we remember this? When we multiply exponential notations with the same base and maybe different exponents, we copy the base and add the exponents. Example, 3 squared times 3 to the 4th. How much will that be? Give it a shot. I know that this is new. It's okay if you're wrong. What will the answer be here? Copy the base.
To the 6th power?
Indeed, excellent. Very good. So I copy the base and add the exponents. Perfect. Here's another rule. So this is rule number 1. Here's rule number 2. When I divide a to the nth power over a to the mth power, it's the same idea. I copy the base. Don't touch the base. Don't simplify the base. Don't divide the base. Don't add the base. Nothing, nothing, nothing. And we subtract the exponents. And it has to be in this order always. From the exponent of the numerator, I have to subtract the exponent of the denominator. Never reverse that sequence. And of course, this is dynamic. It can go from left to right, or it can go from right to left. Here's an example. Let's say I have 3 over 3 to the 10th power. Let's think for a moment. What would you write?
Three to the 10th power?
So we copy the base, and we have to subtract from the exponent of the numerator, which is
1.
very good. We subtract the exponent of the denominator, which is
10.
perfect. So then we copy the base, and
It's 3 to the 9th power.
careful, negative
3 to
9.
the- Oh, negative 9.
So I'm gonna explain this in a moment. So I beg for $10, and you say, okay, here it is. I'm giving you $10. So that means that I am $10 in minus. Tomorrow I say, I don't have the entire $10 to give you back, but I want to give you one because I have it. So I still owe you $9, which means I'm still in the minus with $9, in other words. So I'm going to explain this in a minute. Right now, next item is going to be that. Now, there is a problem with the answer. What is the problem with the answer? Here it is. No negative exponents in the final answer. No negative exponents in the final answer. Not acceptable. Not acceptable. So then what do? Well, I'm going to use rule number 3. What does rule number 3 say? It says this. It says a raised to negative nth power is a fraction. Does not mean a negative number as the answer. It could be, but please never connect a negative exponent to the final answer being negative. They don't have any connection. So this is a fraction. The numerator is 1. And then we get this quantity in the denominator with a positive exponent. So this is another very important rule. Yes, dynamic as well. It goes back and forth. From the right-hand side to the left-hand side, from the left-hand side to the right-hand side. So, coming back to our answer, can anyone use this rule and tell us the final answer for 3 raised to negative 3? 3 raised to negative 9. How would you write the final answer? Can anyone help with the final answer of 3 raised to negative 9 based on this rule?
Isn't it 1 over 3 raised to the
Absolutely, absolutely. That's all it is. 1 over 3 to the 9th power. Absolutely, that's it. I did not forget to go back and explain these options again, but that's fine. But let me finish with one more rule. So this is the multiplication rule of exponential notations. This is the division rule of exponential notations. This is the negative power rule of an exponential notation. Again, the product, the quotient rule, the negative power rule. Okay? Product, division, negative power. And we have one more to discuss right now, which is number 4. A to the nth power, everything to the mth power. So let me go back for a second, just write them here for you. So this rule is product. This rule is quotient. This rule is negative power. And this one is power rule. Okay. In this particular case, we copy the base and we multiply the exponents. Here's an example. 3 squared raised to the 4th power. Can anyone use the rule and tell us what it is?
3 to the 8th power?
3 to the 8th power. Copy the base, thank you very much, and multiply the exponents. Copy the base, multiply the exponents. Good. A raised to 0 is always 1. So let me make this fifth rule. A raised to 0 is always 1. There is a catch. If and only if the base is not 0. So what I'm saying, that 0 raised to 0 is another indeterminate case. Calculus 1, indeterminate case. Please do not worry about this in this class. The reason I write it is because I want you to remember that the base cannot be 0. 0 raised to 0 may or may not be 1. It's an indeterminate case. Okay? So we had 2 indeterminate cases so far, 0 over 0 and 0 raised to 0. These are not part of this class. Okay, and I just want to add here one more. A times B to power n, which is, let me give an example. A times B to the second power, which is not A plus B to the second power. You can say, how can I confuse them? I can't. This is multiplication, meaning factors. This is addition, meaning terms. I will never make the mistake to confuse these two. Correct. But even my calculus students make this mistake, however. So, this is this, not this. So, we copy 1 times n. I'm using the same rule, times 1 times n. So A times B, everything squared. Can anyone tell us how would you write it without parentheses?
A squared times B squared?
That's it. Thank you very much. Perfect. A squared times B squared. That's all it is. Okay, I want to go back and discuss a little bit about adding those again. Number subtracting that we discussed sometime last class. So, if I add 2 to 3, I have no problem. If I subtract like this, I have no problem. I beg for $2, and then the next day I'll say, I'm sorry, I don't have the $2 to give you back, but I really, really need 3 more. So here I am now. I owe you 5. I know we discussed this, but I want to discuss it again. So this is easy. When both have the same sign, no difficulty. I'm adding on. I'm piling on. Either debt or positive values. But again, what do I do when I have 10 minus 3 or negative 10 plus 3? So when they have opposite signs. Some of you were not here last time, so let me go over this again. Now, here, it's easy because from 10 I subtract 3. I have $10, I give you 3, so I end up with 7. But what do I do here? And we discussed this last time, and we said, first I have to establish the sign. It's safer that way. Okay, how do I know which sign the answer would have? It depends on which of these two numbers is a larger quantity in absolute value. That one will dictate. It's more powerful. So I take on the side, negative 10 in absolute value is 10, and positive 3 in absolute value is 3. So therefore, this is more powerful. It will transfer its sign over the final answer because it's more powerful. In other words, I'm saying, I owe you $10. And today I say, I'm sorry, I only have 3 to give you back. I am still in your debt with 7. This is how we think. The sign should be always first. And how do I know the answer? In this case is easy, in this case is easy, in this case is easy. But this requires, at least at the beginning, a little bit of thinking. Which one is stronger? Well, this is more powerful. I owe you 10, I'll give you just 3 today, and I still owe you 7. Okay. There is a problem in 1.3 practice, I think, that is like this. I totally disagree with it. This is not the correct writing, so please do not make this mistake. The first one does not need parentheses because there is nothing in front. But I cannot have 2 crashing operation symbols like this. They have to be separated by parentheses. Again, the next one needs parentheses. And the next one needs parentheses. So when you encounter this, take it and forget it. Meaning, look at it, but remember this is not the correct syntax, the correct writing. So, first I established a sign. A negative times a negative times a negative times a negative, right? There are 4 negatives. I don't have to think. The answer must be positive. We don't write positive, so I just put it dashed. And I have 8. To which power? Yes, indeed. So I want to show with the graphing calculator how to perform this operation. Okay. So you can use parentheses. There is no need because we already established the sign. But you need parentheses if you want to use the negative. The caret is what allows us to put the power on, and we have 4. Since you already established the sign, this is the only thing you need. You don't need to put parentheses and then -8. The point I was making with the first one is, if you need to start an operation with a negative number, you have to use this symbol, not this symbol. So when I write 8 minus 6, I have to use the operational symbol. But if I need to write the opposite, I want to put first, I'm using the commutative law, and I want -6. So, I'm sorry. So the answer is indeed 2. But if I want to reverse this, I have to reverse it correctly. -6 first, plus 8. The answer has to be the same. But notice that since I started with a negative number, I cannot use the operational negative. I have to use the symbol that is the negative symbol. Of course, the answer has to be the same. Let's just see what happens. No, let's just see. It won't even allow me to start. Yeah, it won't even allow me to start with the negative sign and the operational sign. Okay? Any questions? Anybody? Any questions, please?